Hey everyone, welcome back to the fifth video in our series on the reactions of chapter 8. Okay, so this video is going to be going over the addition of halogens to alkenes. Okay, so in this reaction, we're adding, so this adds X2, which X2 can be Cl2, Br2, or I2 across a double bond. And this reaction is anti-addition, which we will talk about in a second. And Markovnikov anti-Markovnikov does not apply to this reaction, but the enantiomer is also formed. Okay, so we also form the enantiomer. I guess we could say enantiomer is also formed. Okay, so let's look at a couple of examples here. So the first one I want to look at is this one. So if we add X2, so Br2 for example, and my solvent is always going to be CCl4. Okay, so this is carbon tetrachloride. Carbon tetrachloride is almost always a solvent for these. So I add Br2 or Cl2 or I2 and carbon tetrachloride. And then that gives me this product. So I take each carbon that was in the double bond and I add a halogen to each of those carbons. Okay, so this carbon gets a halogen and this carbon gets a halogen. Okay, so this right here, you'll notice that these are anti, right? This is anti-addition. Okay, so if I have one on a wedge, the other one has to be on a dash every single time. Okay, every single time. And this is a meso compound, so I'm not going to draw the enantiomer, but typically we would get the enantiomer of this as well. So let's do one where we would get the enantiomer. I'll do a ring. I'll do this ring. And we'll do Cl2 and CCl4. So just add a Cl to both carbons. And then I also get the enantiomer of this one as well. Okay. So I just add a halogen to both carbons and I'm done. Okay. This is, I think, like I said, I think this is fairly straightforward. This isn't too bad. So hopefully this kind of makes sense. We'll do one more example. Let's do one that isn't going to be a meso compound either. Okay, so here it doesn't matter that this is on the end and these aren't equally substituted. That's completely irrelevant. Okay, so we still just add one chlorine here and we add the other chlorine down here, right? We would get the other chlorine like this, but that last carbon there is not chiral, so that doesn't really matter, but we would get this enantiomer. And I'm drawing this on a wedge and this on a dash, even though they're not chiral, but just for the sake of understanding, right? They're going to be trans to each other. Okay. So this is my entire reaction. Okay, for alkenes. This also happens in alkynes, but we'll talk about that in chapter 9. So the last thing to mention is the mechanism. So I'll do the mechanism for this first one here. Okay, the mechanism is pretty straightforward. So let's scroll down and take a look at this mechanism. All right, so if we do the mechanism for the first one, then I have Br bonded to Br, and each of these bromines has 3 lone pairs, right? So bromine has a lone pair, so it's going to attack the double bond, but bromine is also going to get attacked at the same time. And then this other bromine leaves. Okay, so this is very similar to the second step technically of oxymercuration, demercuration. So the attacking and then the attacking back is quite similar to that. So in that vein, we get this intermediate. So we form a ring, okay, and this has a positive charge and it has 2 lone pairs on it. Okay, so we have a positive charge with 2 lone pairs. And then the thing is that in our starting material, okay, I have a methyl group and another methyl group, and they're trans to each other. So in this ring, they're going to continue to be trans. Okay, so those will always be trans in the ring. Okay, because in the starting material, they're trans. If they were cis, like if I started off with this one instead, right, then my ring would look like this. Or both of those on a dash, either one. But this is what my ring would look like if I started off with a cis alkene. Okay, so there's like that distinction to be made. So just know that. But anyway, let me get rid of this one so we have room. So we just had a bromine leave, right? So now what this bromine can do is, now that it has these lone pairs, it can come into one of these carbons and attack. And it will always attack the more substituted carbon, but these two are equally substituted, so it doesn't matter. And then that's my entire mechanism, and I'm done. That's it. Okay, that's the whole mechanism. Just to be clear with the more substituted thing, if I had this one instead, and I do the same thing, then this is going to attack. It's going to get attacked back. Bromine leaves. So then I form my ring again. So that's my ring. And now this carbon is going to get attacked because it's more substituted. Okay, so this bromine that's going to come in is going to attack there because that's a more substituted carbon. So bromine attacks there, that goes up there, and then again, I still get my product, which would look like this. Even though this isn't chiral, I'm writing it that way just for clarity. So this is my entire mechanism for this reaction, okay? Nothing crazy. These intermediates here with these rings are important, okay? So these are known as halonium ions. So halonium ion. This one specifically is a bromonium ion. So you can imagine if you had a chlorine, it'd be a chlorinium ion, or a bromonium ion, or an iodonium ion. So it's important to know this intermediate. You will definitely be asked about this intermediate. So know what this looks like in this second step here, and know what's going on here. Okay, so definitely know this. All right, so while this is called a halonium ion, in this specific case, it's a bromonium ion because there's bromine in it, right? So if you know that, and you know that it's anti-addition, and you know what it adds, then I think you're going to be good for this reaction. So this is everything you need to know for the addition of halogens reaction. Definitely study that mechanism. It's an important mechanism. And in the next video, we're going to be talking about a variation on the addition of halogens reaction. So I appreciate you watching. Hopefully this was helpful, and I will see you in the next video.